If you haven't already, I would suggest finishing the 3 units of GD&T in Solid Professor, because the next assignment will be utilizing the information provided in those units to fully define several assigned parts using both dimensions and geometric tolerances. So go ahead and finish up those units, and then you can jump into this these exercises, and it should make the whole process much easier. So I have 2 parts here. I'm going to show you how to go about this and kind of what I'm looking for. And then on Canvas, I'll have several different parts I want you to model up and then use DimXpert to fully define. So on this plate here, we're going to do a similar thing to what we did with the last exercise where I had you define them just using dimensions, but now I'm going to make it a little easier. Well, the process should be a little bit easier by using geometric tolerances. I don't think we'll be using all of them, because if you've watched the videos, you know that several of them are kind of rare, or just kind of a refinement of more powerful geometric tolerances such as position and profile. I'm still kind of looking through some different parts I can use to best demonstrate when to use this, like something like position over run out. The ones I found so far that you're probably going to use mostly position, but I'll keep looking for other ones that would be suitable for things like profile and run out. So I'm going to get started here. The first step, although don't have to do this, make this your first step, but it's a good place to start, is to select your datums. So for a part like this, let's just say the bottom surface is going to mate. This surface is going to position, and then we'll use these 2 surfaces here to position and orient the rest of the part. So let's jump over to a datum. Well, this is the MBD Dimensions tab. Make sure you're over there. I'm going to start with an A. It doesn't have to be an A, but it's a good place to start. The alphabet, you know. Alright, so that's the bottom surface. I'm going to make that A, this one B, and this one C. So if this was placed into a datum reference frame, or to kind of test the part or to measure it to make sure it's within specification, they'd place it on the A datum first, then the B, and then the C. And then from there they can actually then be able to measure the part consistently from piece to piece. Okay, so now I want to we'll do locations. So it's going to be the location from this surface, the location from datum B to this surface. So I'm going to click there. I click the edge, but it shouldn't matter. And click there, and you can see it selected those 2 planes. Place my dimension. Same thing for this one. I'm just going to click the edge here. Should have made this part thicker, I guess. Easier to click on. That's good. And then from datum A to this top surface. So now I kind of want you to try to use form and orientation tolerances as when they'd be meaningful, or at least somewhat logical for the use. So say datum A, a good tolerance for geometric tolerance for that would be, we want it to have maintain a certain level of flatness. So I click on the geometric tolerance button, come here, select my symbol for flatness, which if you hover over these, you should know what these are, but if you hover over them, they'll tell you which ones they are. And then for this, I just want a flatness tolerance of 0.02. Don't worry about assigning tolerances right now. This is just trying to get used to using these tools. So I'm going to click on this surface and place it. And okay. Now with that there, it's kind of ugly looking. I need to probably dig a little deeper to see if I can find this, but I wish it would kind of, I think if I'd done this first and then applied the datum, it might have done this, but depending on your order of operations, I suppose you'll get different results. But if I select datum, the datum tag A here, it gives me an option of where to place that, and it tends to look a lot cleaner if you have it come off of your control frame here. So I'm gonna place that there. In terms of orientation, I want to make sure that my datum B is going to be perpendicular to my datum A. So let's go back to geometric tolerance again. I'm going to click here, perpendicular. I'll leave, it's not an axis or anything like that, so it doesn't need the diameter symbol, and I'm not going to use maximum material condition for something like this. So I want it to be with a tolerance of 0.02, a perpendicularity tolerance of 0.02 to datum A, or with reference to datum A, however you want to say it. And now I'm going to put datum C to be perpendicular to datum A and B. So I'm going to put B in the secondary here and select this surface and hit OK. Once again, I can do it doesn't seem to take my last one. I must not have clicked. You kind of get into a workflow with this stuff. If you don't click, it's easy enough to set these up and then hit OK without ever clicking on something. I wish it would give you either even just an error to say, are you sure you want to close out before you click on that? Because I've done so many of these where I've set up what I wanted and then hit OK and then nothing was done and I had to go right back and do it again. So I'm going to click. Now you got to remember, you got to place it and then you can hit OK if you're done. So let's see if this works. Yep, so I selected both of those and now I want them both to be, oh, no, I guess I was wrong. No, it worked. What the heck is that doing? I don't think I want it to do that. I must have put, what is that? And now it went away. Okay, sure. If that happens to you, I guess click on it a couple times and maybe it'll go away. And I want that there as well. Okay, let's check our status here now. So the plate itself is fully green. Now we got to deal with our holes. So I need a size on those holes. So I'm going to click size dimension, click on the hole, and place it. It automatically recognizes them as a pattern, so it's giving me that 4x and the size dimension there. If it doesn't do that for you, you can use the pattern feature option and go in there and manually select them and set them up as a pattern. So in this situation, we want to actually have a position. We're going to use position to fully define these holes. So I'm going to come up to our geometric tolerance, click on position. This is an actual a circular feature, so we're going to have our diameter symbol on that. And I also want to use maximum material condition, so a part like this could use a functional gauge to check to see if it would function. And then I want this to be positioned to datum A, which actually adds, makes the axis of the hole perpendicular to datum A. And then from there, we'll position from datum B and datum C. And I can click on the holes or click on the dimension. I'll click on the dimension and it applies it right there. Okay, so when you click on show tolerance, we are fully green, but we are not done yet because we haven't really said to the person making the part kind of roundabout or where the true position of each hole would be. So we're going to use our basic dimensions for something when we're doing that. So click here and here. I can do, if I really wanted to, although not necessary, click on this one here as well, and then I'll merge these two, but that's not necessary. And we'll do baseline dimension with these. So I'm going to click up here, place that, click here and here, place it, and one more, place it. And like I said, I can actually merge these two. Well, it didn't work to do it that way. Right click and combine dimension. And I'm actually going to remove the instance count on that. From here, I want you to kind of position things to make it look kind of nice and clean. You can drag these around. It's a bit, you got to be kind of right on there to do it, and if you're not clicking on the same surface, it's not going to let you just drop it anywhere. So just be aware that you got to be kind of right on there to make sure you get it where you want it. Let's see here. I'll play with that on my own, but that's what I kind of want you to do is to, well, why didn't do that? Right click. Okay, I'm just going to delete one of these. That should have combined them. I'm not sure why I was doing that. Okay, so I'm going to go over to a more complex part here, but as I said, this is kind of the basis of the exercise, is combining your dimensions and geometric tolerances to fully define a part. And I'd like you to try to use at least a few of your form and orientational tolerances along with what will probably most likely a position tolerance. So here's the little more complex object that I'm going to show you how to apply your dimensions and geometric tolerances to. Before I get too deep into this, I want to show you something with defining these patterned holes. I'm still trying to find a really good way of doing this, because if you remember, when you had these patterned holes, in the drawings, it would actually apply that path on there that you could dimension the diameter of the hole placement. I have not found a really good way of handling that using DimXpert yet. It seems kind of odd that they don't have that option readily available, but I'll keep looking. But I have a kind of just a way that I'm going to have you do it that works. It's just not as clean looking as I was hoping. One way that I've found, but it causes, it's not quite right, because what would be required is a basic dimension, and this process does not seem to allow that. So, but I'm going to show it to you anyways. You probably won't end up using it, but maybe if you want to try it and see if you can get something to work, more power to you. So I'm going to start actually with the auto dimension scheme. I'm going to change it to plus and minus and polar. I need to set up a primary datum, which really doesn't matter. I'm just going to select something, and then I'm going to, under scope, I'm going to change it to selected features and select the patterned hole here, and then hit check. And what that did was added what I was looking for, this path of the pattern. But the problem is it's a tolerance dimension, and what I want it to be is just a basic dimension, because I'm going to use position tolerance on the holes themselves. And when you're doing those dimensions when using position, you have to use a basic, because you don't want to really double up on your tolerances. The problem is, as far as I can tell, I can't turn this into just a basic. I can turn it into none, but it doesn't have that box around it. There is this, but those are only two options. That's not a basic dimension. So it would be great if it worked, but it doesn't seem to work. So that sucks. So I'm gonna hit check and close out of this. I'm gonna just delete all those. I'm gonna delete all these too. Okay, so I'm gonna once again start with selecting my, I should hit yes to all. Alright, I'm gonna start with selecting my datums. So I'm gonna put the bottom surface will be my datum A, my mating surface, and then I'll just use this center hole here as my secondary datum, and that's why I'm just going to leave it at that. Okay, so a couple of the basic things first. Let's get the thickness of the plate with a location dimension up to the very top of this. we'll do from datum B to the intersected edge here. So I'm going to click on this inclined, click on intersecting line, click that surface. Place that. Do the same thing for the other side. Check and place it. Let's do some size dimensions for that, and then our patterned holes. When I was first setting up this part, I don't know if I have any examples like this in the ones I'll be assigning, but if it does happen, I had, and something I'll have to look into a little more, I had my patterned holes and my center hole the same size, and then it treated all of them as the pattern, and I didn't really want that, so I probably should have probably gone in and done the pattern feature and did it manually and left this out of that. But just to make my life easier, because this is just a demonstration, I set this hole to a different size. Okay, where was I at? Suppose we'll do a size on this, and then we'll have a position tolerance on this guy. Oh, we gotta click on width. So we'll position to tilde key and put that on the top. We'll position this feature of size about the midplane of that feature of size about datum A and B. I'll get to that in a second. We're going to need an angle. The way I had this set up, this is determined by an angle, so we'll have to use angularity tolerance on there. And then, as I said, I can't find a good option to dimension the position of these holes with a basic dimension, so for our use right now, I'm just going to use a linear one from the datum B there up to that one, and we'll call that good. Okay, so let's see where we're at with this guy. Let's do a size on our fillets here. And then I think I did, so I didn't have to do it twice. I'm going to do it's just a manual, or it'll be a collection. So I'm going to select this surface and that surface so that it gets it done in just one swoop. So I'm going to add angularity. We'll leave it at that, and this will have an angularity tolerance in reference to datum A. Click there and place it. As you can see, it added the 2x on that. Alright, let's keep on going. Looks like I forgot to do the size dimension on the outside cylinder here. And now I think we can start applying some of our tolerances. I believe if we apply position, that should kind of handle this one. Let's give that a go. So let's do position, we'll leave that there. Let's do max material condition on that one. And this is going to be to A and B. I'll click on the dimension. Let's put some diameter ones on here. We'll continue to use max material condition. Click on that one. We could say that for this one, these holes, we want to make sure that they never get too big, and so we'll use the least material condition modifier on these so that to protect the wall thickness here. So let's do that. I'll undo that one, put least material condition on there. Let's see here, what else do we got? I think that might be it in terms of some of my needed position. Let's say okay. Let's see where we're at. Okay, so those are still yellow. What am I missing on that? So it looks like I steered us wrong a little bit with setting up that collection. I'm going to delete these real quick. And I will assign an angularity tolerance to both of those and then combine that tolerance. So angularity, keep the tolerance the same, and we want that in reference to datum A. So clicking this surface, place it, that surface, place it, and OK. OK. Select both of them, and right-click and combine GTOL, or geometric tolerance. And now we're fully green, but once again, we're not entirely done. I need to add my basic dimension, which I was playing here, so I lost that one. Nope, let's try that one more time. Basic dimension from here to there. Place that. And then we need to know what the angle actually is for that. So I'm going to click from my datum to the surface and place it. Once again, I'll go through and kind of clean it up, make it look nice, and make sure that it is fully defined and you're not necessarily missing any dimensions. One dimension we are kind of missing from this, let me tidy that up a little bit, is the angle between the holes. So I wish there was a couple more tools built into DimXpert to make some of these things a little easier. That should also kind of technically be probably a basic dimension, but I don't really have a good answer for that right now. So for something like that, we'll just kind of ignore it until I can let us know what would be a good process of actually achieving that dimension. But there'll be several parts I'm going to have you run through this process on to kind of get a good handle on fully defining parts using dimensions and geometric tolerances.